In lesson 3.8, solving logarithmic equations, you'll learn to solve log equations with various bases. Now, the first property we're going to use is the one-to-one property of logs. Similar to exponential equations, if the base of our log is greater than, for any base greater than 0, not equal to 1, the log base b of x equals the log base b of y if and only if the x and y values of those logs are also equal to each other. So because of this property, we can solve log equations with the same basis. So we have a log base b of x, like it says, equal to log base b of y. We can solve by getting these two values equal to each other and solving the equation from there. So for example, here I have two natural logs, so obviously the bases are the same. Therefore, 3x plus 8 equals negative x plus 4. And solving this equation, I would add the 1x to both sides, so we end up with 4x plus 8 equals 4. I subtract the 8 from both sides. That gives me negative 4, and I get that the value of x equals negative 1. Now, when solving these equations, we end up again that x has to equal to negative 1, and by plugging it in, again, it is true. 3 times negative 1 is negative 3, plus 8 is 5, and negative of negative 1 is 1, and 1 plus 4 is 5. So you see you end up with the natural log of 5 equals the natural log of 5. So we can check that our solution is correct by substituting it back into the x, like in any equation, and verifying that the left side equals the right side. So for this example, same technique. So notice again that we have the log base 9 equal of x squared plus 98 equals the log base 9 of 20x minus 2. So that means that x squared plus 98 equals 20x minus 2. Now, this is not a linear equation. This is a quadratic equation. As you clearly see, we have x squared, and we have a linear term right there. So we need to set this equal to 0 in order to solve it. So I'm going to subtract the 20 from both sides. I'm going to add the 2 to both sides, so I could get this equal to 0. So all I've done again is just simply move this to this side, so that makes it negative 20. Move this to this side, which it makes it positive 2, which combines with the 98 to give us a total of 100. Now, with my quadratic equation equal to 0, I can now solve for it using factorization. So the factors of 100 that add up to negative 20 are negative 10 and negative 10. So x equals to positive 10. Well, let me write the equation so we remember what we're doing. X minus 10 is equal to 0, which means that x equals to positive 10. And well, the second equation is going to give us the same value. So here, x simply equals to positive 10. Now, in order to use the one-to-one property right here, we are going to have to condense the left side of our equation. Because remember, the idea is to get one log base b of x to equal to the log of the same base of another value, which we'll call y. So right here, I need this to be condensed. Well, I can apply the product rule of we can apply the product rule of logs. So since I'm adding again this log with this log, I can condense it to one log by multiplying 3 with 3 minus 3x. And multiplying 3 with 3 minus 3x, that gives us a total of 9 minus 9x. And now we can use the one-to-one property and solve this equation for x. We'll subtract 9 from both sides, which is a difference of 45. Divide by negative 9, and x equals negative 5. There's your answer. There you go. I'm sorry, I'm looking at this answer and like, hold on, that doesn't make any sense because this is 44. I misadded here. So 44 and dividing 44 by negative 9, that is a total of negative 44 over 5. There, that makes more sense. So there's your answer. Similarly, if I'm subtracting two logs on one side, I can use the quotient property. So here I can write this as one natural log by dividing 8 and 4x minus 4. Since that equals to the natural log of 14, then I can now set these two values equal to each other. So basically, ignore the natural logs. To solve this equation, it's going to require us to do some cross multiplication here. So we'll end up with 8 equals, well, 14 times 4. That is a total of 56. And we're going to multiply negative 4 with 14 also. So that's negative 56. So let me write our equation over here. So we have 56x minus 56 equals 8. We're going to add 56 to the 8, which is going to give us a total of 73. So 56x and dividing that by 56 is 73 over 56. And there's your answer. Okay. All right. Now, let's say that we do not have logs on both sides, and we cannot use this one-to-one property. Well, to solve equations that are written in the format of log base b of g of x equals to a numerical value y, we can rewrite that by using again the definition of logs and writing our expression as a exponential equation instead of logarithmic equation. So we'll start by isolating the logarithmic expression, rewriting the logarithmic expression into an exponential equation using again our definition, that property that log base b of g of x equals y equals to g of x is the same as g of x equals to b to the y power, and evaluate b to the y power and then solve the equation for x. So like in this example right here, to solve this logarithmic equation, we cannot use the one-to-one property because we do not have the log base 4 of 2. We just have 2. So I'm going to do is just simply rewrite this as an exponential equation. So I'm going to get this value here, which is just x, and equal it to the base of 4 raised to the second power. Evaluating 4 to the second power is 16. So the answer to this equation is that x equals 16. So let's look at example number 6. Here we need to, again, before we can do this last step here of getting this value and raising it and equaling to in the base to the power, we need to isolate the log. So here is the log, the natural log of 3x minus 9. We want to isolate this. You'll notice that we're doing two things to this. We're multiplying it by 5 and we're subtracting 7. So we're going to start by adding the 7 to both sides. And we have then 5 times the natural log of 3x minus 9 equals positive 5. We will now then divide by 5. And the 5's reduce. And we're left with ln of 3x minus 9. 5 divided by 5 is 1. And since ln is the log when the base is e. Let me continue over here. That means that 3x minus 9, this value here, equals to this base raised to this power. So e to the first power. And let's evaluate that. Well, e to the first power, again, is 2.71. So we're going to approximate this to 2.718. And to solve this equation, we will continue by now adding the 9 to both sides. So I would add 9 to my answer. Oh, hold on, not right. I would add 9 to that answer, which is approximately 11.718. And divide my answer then, after that, divide my answer by 3. So the approximated value of x is 3.906. And that's our solution to our equation. Let's practice another one. So for number 7, again, our natural log base 3 of negative x minus 4 needs to be isolated. So just like before, we're doing two operations here. We'll start by first adding the 8 to both sides. And then we have 3 times the log base 3 of negative 8x minus 4 equals positive 3. We'll divide by 3. And the log base 3 of negative 8x minus 4 equals 1 yet again. So now we get our equation by getting negative 8x minus 4 and equaling it to 3 to the first power. Well, that's simply going to be 3. We'll add 4 to both sides. We'll end up with 7. Divide by the negative 8. And our answer is negative 7 over 8. Now, similarly to the one-to-one property, we cannot solve an equation if we have multiple logs on one side of the equation. And if I move it to the other side, well, that's just going to simply add it, subtract it to the 5 instead of add these together. So what I'm going to do is use my product property of logs and condense this left side of the equation to 1 log. So I can write this as 1 log base 2 by multiplying the x with the x plus 4. And that gives us x squared plus 4x. And now we can rewrite our equation as x squared plus 4x equals 2 to the 5th power. So I'm trying to get the calculator out. So 2 to the 5th power, 2 raised to the power of 5 is 32. So x squared plus 4x equals 32. And to solve this equation, we're going to subtract 32 from both sides. So x squared plus 4x minus 32 equals 0. So we'll break this up into its factor. We have our quadratic equation, set it already equal to 0. So we'll break it up into factors. And the factors of negative 32 that give us 8 are a positive 8 and a negative 4. So x equals to negative 8 and x equals to positive 4. Now, I forgot to mention this in the previous examples because we haven't come across this. But now because I have two solutions, I have to verify that both solutions actually are valid solutions and not extraneous solutions to this equation. So for example, if I plug in positive 4 in for the value of x, this value is positive 4 and this value is going to be 8, which is good. Those numbers are 8. Remember that for the log base b, this value has to be a positive number. This value cannot be negative either. The base can be negative, and as a result, this number can't be negative because, again, since the log base b of x equals y, that means that x is going to equal to b to a power of y. So that means, again, since our value b is a positive number, raising it to the power of y simply means we're multiplying this positive number a y number of times. And if we multiply a positive number by itself, the answer is always going to be positive. So this value here, as a result, is always going to be positive as well. So it's fine when x is equal to 4. However, when x equals negative 8, it is not fine for two reasons. This is going to be negative 8, and this is going to be negative 4, and that has no possible solution. The log base 2, let me move this out of the way real quick. The log base 2 of negative 8 does not exist, because that would mean that we have negative 8. Negative 8 is going to equal to 2 raised to some power. Well, 2 to the third power is equal to positive 8, and 2 to the negative third power is 1 over 8. There is no way to multiply a positive 2 an unknown number of times to get and change it to a negative value. There's no way these things are ever going to equal to each other. So that means that this cannot exist. Therefore, this is an extraneous solution and not part of our solution set. So not every value that we get for x is actually going to help us, is actually going to give us a solution to the equation. There will be situations where the equations just have no solutions. There's no way to get our log to equal to a numerical value. Okay, we didn't have to come across this one. This one right here does work. If I plug in a negative, that makes it into a positive, and then subtracting 4 is still going to give this value a positive when we plug in this negative value. So it's not just because the number is negative, it's because when I plug it in, it gives me a negative output value. So we can have negative solutions, x could equal to negative values. It's just, okay, what happens when I plug in that negative inside there? And don't assume just because the answer is positive, that x equals to a positive number, that when I plug it in back into the original equation, that this value is going to stay as positive. So always go back and plug in the number and verify that we don't have this situation, an extraneous solution. So let's look at one more example. On this example here, just similarly, we have two logs. Like in number 8, we have two logs, but this time we're subtracting those two logs, so we're going to use the quotient property to condense this. So we're going to write the log base 2 of x squared over 3x minus 5. So x squared over 3x minus 5 equals to this base of 2 raised to that power of 2, which is 4. And here, because we have a ratio, we're going to cross multiply to solve the equation. So we would then end up with x squared plus 12x, equals 12x minus 20. So moving the 12 to the other side makes it negative. Moving the 20 to the other side makes it positive. And now this is set equal to 0. And we can solve this quadratic equation by factorization. Then the factors of positive 20 that add up to negative 6 are, I'm sorry, negative 12 are negative 2 and negative 10. So there x equals to positive 2 and x equals to positive 10. And again, because we have two solutions, or even when we have one solution, we should always go back and check that plugging in these numbers makes these values positive. Well, the first one is guaranteed to be positive because anything to the second power multiplies two identical things. So two negatives is a positive, and a negative times a negative, like I said, is a positive, and the positive times a positive is obviously positive. But let's see what happens here. If I plug in 2, this becomes 6, and 6 minus 5 is 1, positive 1, so we're good. And if I plug in 10, that's 30, and 30 minus 5 is definitely a positive number, that's 25, so we're good. So in this situation, both of these are solutions to this equation, and there is no extraneous solution here. And that concludes our examples. So again, key thing is remembering on when solving and using this technique of rewriting the equation into a logarithm, into an exponential, I'm sorry, from log to an exponential, that there might be situations that x, again, is not an actual solution to the original equation. So you have to plug it in and verify that these numbers are always going to be greater than 0, are always positive values. Well, that again, thank you again for watching. If you have any questions, please send me a message on Remind or through email. And like always, hope you have a great day.